Your FastAPI endpoints are working great for humans, but how do you actually test that they're ready for AI clients to use? We'll see exactly how to verify your MCP server works as expected by using the FastMCP client to interact with it programmatically. You'll watch as we list available tools, create a product, and query filtered results, all through the same interface an AI would use.
Hash assumes the FastAPI app from above is already defined. From FastMCP, import FastMCP. From FastMCP client, import client. Import Asensio. Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app. Async def demo. Async with client, MCP as client. Hash list available tools. Tools equals await client list tools. Print F available tools. T name for T and tools. Hash create a product. Result equals await client call tool. Create product products post. Name wireless keyboard. Price $79.99. Category electronics. Description Bluetooth mechanical keyboard. Print F created product. Result data. Hash list electronics under $100. Result equals await client call tool. List products get. Category electronics max price 100. Print F affordable electronics. Result data. If name equals main. Asensio run demo.
This demonstrates the API transformation pattern, converting a res TFUL FastAPI service into an MCP-compatible toolset. The technique bridges two architectural paradigms by automatically mapping HTTP endpoints to AI-callable functions, preserving the original API's business logic while adapting its interface for LLM consumption. What distinguishes this approach is its dual-mode operation, where the same backend simultaneously serves traditional HTTP clients and AI agents through different protocols. The pattern works through declarative conversion rather than manual rewriting. FastMCP analyzes the FastAPI application's OpenAPI schema at runtime, translating routes, parameters, and response models into MCP's tool resource abstraction layer. This maintains separation of concerns. Your API logic remains unchanged in the FastAPI layer, while the MCP layer handles protocol translation, tool discovery, and client integration. The conversion preserves type safety and parameter validation through pydantic models, ensuring the transformed tools maintain the same contract guarantees as the original API. This approach solves the integration tax of exposing existing APIs to AI systems without requiring parallel implementations. It's particularly valuable for brownfield projects, where rewriting APIs as native MCP tools would be prohibitively expensive. The trade-off is that auto-converted APIs may expose more complexity than purpose-built MCP tools, so this pattern works best for prototyping or when you need to quickly bootstrap LLM access to existing services. For production AI integrations, you'd typically use this as a starting point before refining the tool interfaces. Let's break it down.
Hash assumes the FastAPI app from above is already defined.
This comment establishes the prerequisite that a FastAPI application instance named app must exist before this code runs. It prevents undefined variable errors by explicitly declaring the dependency, following the pattern of assuming external setup for modular code.
From FastMCP, import FastMCP. From FastMCP client, import client. Import Asensio.
Imports FastMCP to convert FastAPI routes into AI-callable tools and client for programmatic server interactions. The Asensio import enables async operations required for both the MCP server and client communication.
Hash convert to MCP server. MCP equals FastMCP. From FastAPI, app equals app.
This converts your existing FastAPI app into an MCP server. FastMCP from FastAPI preserves all your routes and schemas while adding AI callable tool capabilities, eliminating the need to rewrite endpoints. The result is a dual-purpose server handling both HTTP and AI tool calls.
Async def demo. Async with client, MCP as client. Hash list available tools. Tools equals await client list tools. Print F available tools. T name for T and tools.
This defines an async demo function that establishes a connection to the MCP server using a context manager, guaranteeing proper cleanup after execution. The list tools call discovers all available AI callable tools, printing their names for verification. This is the standard pattern for exploring and validating an MCP server's capabilities before making calls.
Result equals await client call tool. Create products post.
This invokes the create products post tool by name. FastMCP auto-generates these tool identifiers from your root names, ensuring consistent references between client and server. The pattern follows REST conventions, where the tool name combines the operation and endpoint path.
Result equals await client call tool. List products get.
This invokes the list products get tool, which corresponds to the GET products endpoint. The naming convention combines the root path and HTTP method, ensuring unique tool identifiers even when routes share similar paths.
If name equals main. Asyncio run dem.
Standard Python entry point guard prevents the demo from executing when this module is imported, ensuring it only runs when invoked directly. The asyncio run bootstraps the async event loop and executes the demo coroutine, handling all async operations in the script. FastMCP client integration. The client class bridges Python code and MCP servers, transforming function calls into AI-optimized tool invocations while preserving type safety through Pydantic models. Tool names derive from endpoint paths and HTTP methods, so inconsistent naming in your FastAPI routes creates confusing tool registries. Always verify available tools with list tools before making calls to avoid runtime errors.
The client that speaks in schemas hears only silence from the server.